The second smallest and innermost of the four Galilean moons, Io was first documented by Galileo Galilei in January 1610. Io proved to Earthlings, along with the moons Ganymede, Europa, and Callisto, that our pale blue point is not the center of the universe, the galaxy, or even the solar system. Since these four satellites were apparently orbiting Jupiter, unlike us, while Galileo kept his observation secret for years because of the then Catholic Church, his documentation of Io paved the way for some very strange findings about this moon in the following centuries. If you like our videos, please support us with a thumbs up, subscribe to Simply Space, and look forward to the videos that will be waiting for you in the future. Let's begin. Our journey through the vastness of the universe. Io helps to understand the history of the Earth, Jupiter's moon. Io is probably one of the strangest places you can imagine in our solar system, considering its huge volcanoes, lava seas, smelly atmosphere, if it exists, and the bombardment by the immense radiation of Jupiter. But what fascinates Earthbound scientists about Io is not the geophysical curiosities, but the way it gives us an insight into the history of the Earth when the Earth formed. More than 4 billion years ago, it was a huge ball of magma bombarded by asteroids that fell into their own lava seas. It is astonishing when you consider that such a distant alien world allows us to study the earliest volcanic phenomena that may have occurred on our own planet. As this list of 10 extra-worldly facts about Io shows, Jupiter's innermost moon is truly a cosmic oddity. Giant volcanoes. Io is extremely volcanically active. We have all heard about the 1980 eruption of Mount St. Helens in Washington, the 79A, the eruption of Vesuvius, which left the ancient city of Pompeii in ashes, or the Yellowstone supervolcano, which lies below the state of Wyoming. However, these pale in comparison to the events on Io. In fact, there are hundreds of volcanoes on the small moon that are primarily responsible for the weather on the surface of Io, and the volcanic eruptions on Io are so powerful that they can be observed through telescopes. Here on Earth, it is said that the explosions on Io cover hundreds of square miles within seconds. A few individual eruptions are said to emit 20 trillion watts of energy and blow debris plumes completely from the lunar surface into space. Sometimes plumes of sulfur rock and debris reach 400 kilometers or 250 miles above the surface. The eruptions on Io are usually 1,000 times stronger than anything that happens on our planet. After eruptions, volcanoes on Io can generate rivers of lava, sometimes flowing for hundreds of kilometers, a true lava lake. Under the surface of Io, there are lunar magma seas. This gelatinous layer of magma, which squashes, crushes, and sloshes under the moon's crust, feeds the intense volcanic activity of Io and literally makes the surface of Io float on liquid rock. This underground reservoir of liquid rock is 50 kilometers, aka 30 miles thick, and explains why Io is by far the most active volcanic site in the solar system. Recently, scientists have estimated that Io, although only about as large in diameter as North America, releases 100 times more lava than all the volcanoes on Earth combined in one region of Io, named after the Nordic trickster god Loki Patera. A single volcanic depression extends 204 kilometers or 127 miles and is constantly filled with magma from below. It is believed to be an exposed sea of lava, millions of times larger than any sea of lava found on Earth. A stinking place. Io could be the stinkiest place in our solar system, period, as if freezing temperatures, hot spots with thousands of degrees, and lack of water didn't make life on Io hard enough for you. Io also smells like rotten eggs. But why the thin atmosphere of Io consists mainly of sulfur dioxide, which is puffed out of the volcanoes. Io's atmosphere also contains very few other trace elements. So this nasty sulfur dioxide stays in the air of Io all the time, and the ongoing volcanic eruptions act like giant gas generators, giving the moon a rather pungent smell. However, these gases also contribute to the creation of Io's atmosphere, even though it smells terrible, which makes it unique among the moons, since most of them simply have no atmosphere. Without water, Io is one of the driest places in the solar system. When Io originally formed around Jupiter, it occurred in a region filled with water ice. Scientists believe that water existed on Io after its formation. However, any water that might have been present there in the past has long since disappeared from the landscape due to Jupiter's intense radiation. This does not mean that scientists have excluded the possibility that life once existed on Io. If there is life on Jupiter 1, then it is most likely organisms deep in the crustal rocks of the Moon. Its temperature, the temperatures on Io, vary radically of all the moons in our solar system. Io probably has the greatest temperature variations on its surface. Some areas of Io dominated by large-scale volcanic activity can reach an astonishing 1700 degrees Celsius, aka 3,100 degrees Fahrenheit hotter than the surface of Mercury. Given the Jupiter radiation and such high temperatures, every visitor to Io needs a fairly intensive sunscreen in general. However, Io is a very cold place with surface temperatures dropping to negative 153 degrees Celsius or negative 243 degrees Fahrenheit. As one moves away from these hotspots in volcanic activity, the NASA space probe Galileo observed that nighttime temperatures on Io around the equator are almost the same as near the poles. Amazingly, this is almost the exact opposite of what happens on Earth, since equatorial regions receive more sunlight than polar regions. Strong magnetism, since the atmosphere of Io consists mainly of sulfur dioxide. This contributes to make Io a very ionized place. The orbit of Io around Jupiter is characterized by intense magnetic fields, making Io an electric generator in orbit. The amazing thing is not only the charged atmosphere which makes way for giant lightning storms, but also the fact that the magnetic forces of Jupiter cause about a ton of surface material to be peeled off of Io. Every second, that's a serious weight loss. The material stripped off, Io is quickly ionized and forms a cloud of intense radiation around the Moon. Scientists call this a plasma torus. Io is also one of the few places where this type of phenomenon occurs in our solar system, which adds to the list of curiosities related to this moon. Unfortunately, scientists tend to agree that this radiation probably means that the probability of life forming on Io, although they have not completely ruled it out, is very low compared to the chances it has on other moons orbiting Jupiter, such as the icy moon Europa. Stretched and squeezed, well, that's pretty weird, as in donating the surface of Io is constantly tormented by the incredible gravity of Jupiter. This means that the moon is constantly being stretched and squashed by Jupiter, forcing it to change its shape, while the magma inside is crushed like gelatin. Other moons such as Europa and Enceladus are also heated by the tides, with huge ice rocks forming in the former moon, and ice geysers erupting on the latter. Io's short year Io has one of the shortest years in the solar system. Do you think that time passes quickly on Earth? Well, on Io its year from orbiting Jupiter is just 42 Earth hours long, while the Earth's moon takes about 27 days to complete one orbit around our planet. The year of Io is incredibly fast by comparison. Interestingly, the year of Io is almost as long as its day one. 8 Earth days, sulfur snow every day. Sulfur snow falls to the ground on Io, in contrast to the water crystals here on Earth, which fall to the ground after freezing in the sky. The snow of Io is a little more strange every year. The moon passes into the enormous shadow of Jupiter for 2 hours. This prevents the sunlight from warming the thin atmosphere of Io. While it's in the shadow of Jupiter, the icy temperatures cause the sulfur dioxide in the atmosphere to immediately fall to the surface. As sulfur snow, the gas that gushes out of the volcanoes of Io also freezes immediately, which contributes to the descent of the sulfur particles. In addition, this shadow effect results in something truly strange. Io's atmosphere essentially collapses during these brief Jupiter eclipses after about 2 hours, when the sunlight begins to reach the surface of Io. The atmosphere of Io is reborn when the fallen sulfur snow returns to its gaseous state, also known as sublimation. Therefore, the atmosphere of Io is in an endless cycle of collapse and rebirth, as sunlight affects not only the temperature at the surface, but also the existence of the atmosphere around the moon, called Jupiter's pizza moon. Because of its bright and patchy landscape, Io has also been considered a fire and ice moon, since it is located in a completely cold place in our solar system, almost 400 million miles from the Sun. But unlike Jupiter's other moons, it emits enormous amounts of heat despite its small size. As a highly volcanic place, perhaps a bit of an understatement. If you read below, modern scientists have observed a hellish landscape in the cosmos, if one ever existed in true science fiction-style Galileo, called Io Jupiter 1, but the moon did not receive its mythological name until the mid-1850s. The celestial body of Io, coined after the priestess of Hera, Zeus's wife, was one of the many whom Zeus, the counterpart of the Roman god Jupiter, had an affair in Greek mythology. Io turned into a cow to avoid being caught by Hera. A fitting story due to the oddity of the moon and the almost shape-shifting landscape of oddities. What do you think of this moon? Leave us a comment. There, but strangely, its sister probe was confronted with a kind of particle stream that extends more than 150 million kilometers into the heliopause. No less strange is the fact that Voyager 1, about 1.3 billion kilometers before the heliopause, entered an area in which the solar wind slowed down noticeably all in all. However, these strange differences reflect only a fraction of the mysteries that still need to be solved in the future regarding the edge regions of the solar system. For example, we don't even know exactly what shape the heliopause has, but at least we now know that the heliopause is surprisingly wrinkled, the enigmatic structure of the heliopause, because after the researchers at Princeton University had registered an immense increase in solar wind pressure of almost 50% within a few months, they used the data to reconstruct the shape of the heliosphere and the heliopause, with the astounding result that the heliopause has gigantic folds that extend tens of astronomical units into space. Just to recap, the length of the astronomical unit corresponds to the mean distance between the Sun and the Earth, which is around 150 million kilometers. So we are talking about folds that are several billion kilometers in size. No amount of Botox will help here, but perhaps the information that the experts have been able to gather about the background to the wrinkled structures will help us. These result in detail from the high-energy particles that flow back in waves from the heliopause and collide with the solar plasma. Consequently, we are enriched with the knowledge that the heliosphere is by no means a static and unchanging entity, but rather a dynamic one that constantly billows, dips, and unfolds again, and indeed the cosmic folds are even racing after the Voyager probes, because as soon as the solar plasma smooths the fold structures again, they continue to expand despite the advanced age of the probes. Voyager 1 and 2 will be spared the folds in their neck because they are simply flying too fast to be caught by them and thus be transported back into the inflating heliosphere. And yet the chase of the folds means that the distance of the probes to the heliosphere is not growing quite as fast as one might initially assume. And we would be delighted if the distance between your finger and the subscribe button now shrinks much faster than you would initially expect. Feel free to click the thumbs up and subscribe so you never miss a new video from us. Again, we'll see you soon.